Now the resources feature will be explained in more detail. We have here our insurance claims process. I'll create the schema with the default milestones, save it, and now we are in the simulation module. I'll create a new simulation scenario. And to this scenario, I'll add resource types. As previously stated, resource types can either be added manually or resources can be mined from the data. Let's pause for a bit on the Mine Resource from Data feature. This option gives you the ability to grab resources that exist in your project. So when I click on this option, a pop-up window appears showing us attributes that exist in our project. Also, we have two mapping options, resources and resource types. If one or some of our attributes contain the resources, for example, our AP clerk is a resource type, and the column contains the names of our clerks, I can drag the resources label to the relevant columns. The program then collects and counts the number of attribute values and adds this to the corresponding resource type in the Simulation Scenario Configuration tab. If in your project the resources types are depicted in one column and the number of instances of each type can be calculated from another column, drag the label Resource Type to a column that groups resources by type. Then drag the resources label to a column containing all matching resources. For example, if you have all your resources in a column called Employees, and you have another column that differentiates employees by their roles, you can label the first as resources and the second as resource types. Alternatively, the same approach can be used to provide any breakdown of the resources. For example, in our case, we want different resource types to reflect the number of clerks working in different departments. So our resource type will be department, and the number of clerks will be calculated from the Clerk AP column. Note that resource demand can be filled for all nodes automatically by clicking on the corresponding option. As a result, activities in the schema graph that occur with any of the found resource types in the data will be marked as ones that need the corresponding resource. But for now, let's imagine that there aren't any clerks involved in our project, so I can add a resource type manually. We want to see how the specific number of agents influences our project. I will mine behavior. And let's, for example, take the Reserves Established event. When we click on any events, the system gives us information about such events referred to as nodes. Even though we click an arrow on the right part of the screen, you always see the properties of the node, and which node it is highlighted here. Every node has incoming connections, and that is depicted in the top, and outgoing transitions that are here at the bottom. One important thing we want to highlight here is the fact that processing does not happen on the node. Processing happens on the arrows. So the process in our case starts on coverage confirmation. There's a timestamp that was recorded in the database. And then there's a timestamp when the event Reserves Established happens. And the difference between these two times is the processing times. That's when something happens that makes the state go from coverage confirmation to reserves established. This time difference includes waiting time, idle time, processing time, anything. And here this comes up with histograms for processing times that are always bound to this arrow, to this transition from state to state. So here we have histograms that reflect the processing time of the transitions between coverage confirmation and reserves established, as well as between processor assigned and reserves established. So that's the first step to understand that the processing is always between two nodes. And then the resource feature comes in. And what we do there is we say, okay, in order to get to, for example, reserves established from any of the previous events or single event, we need some resource. So to perform whatever work or anything else that is supposed to be done in order to get to the specific state of the process, the transition needs some resource. Let's look at this in more detail. As we know, at different periods of time, different numbers of timelines go through different events. This is very well illustrated in the milestone view module when we animate the schema. And in our simulation configuration, we define some resource type, agents in our case, and specify its number, 17. Then, by defining the resource type for the specific node, for reserves established in our case, we say to reach the reserves established node, the transition needs one agent per timeline. And when a timeline passes through the coverage confirmed event, and at some point of time it goes to the path to reach the reserves established event, it simulates taking one agent, if it's available. The same for another transition, from processor assigned. When a timeline goes from event to event along the graph, each transition takes some time. Transition times are defined by sampling the processing time histograms originally derived from the project. Histograms may be, however, altered by the user by cutting the low or high ends or by applying a multiplier. When a resource is required for a transition, the selected resource, for example, single agent, is blocked for the time of the transition. Then the same happens with the second timeline, third timeline, etc. And if resources run out, then the timeline must wait until a resource gets released. So at any single point of time there can be 17 timelines that are on these transitions. They took all agents, but haven't yet reached the point where an agent can be released. That is, haven't yet reached the reserves established event. And if at this point of time a single timeline reaches the coverage confirmed event or the processor assigned event, it will not be able to continue its path to the reserves established event because we don't have a required item for this. We don't have a free agent. And thus, waiting time starts calculating until a timeline with an agent reaches the reserves established event. Then, when a timeline reaches the reserves established event, a single agent is released, and one of the waiting timelines can then start its path, grabbing that released agent. Waiting timelines are reactivated on a first-come, first-served basis. The interesting thing here is that now the system will calculate the difference between the coverage confirmation event and the reserves established event, not as 31 hours on average as we have on our histogram, but 31 hours plus the waiting time. That is, plus the time it has to wait until getting the resource released for continuing the process. The same goes for the second transition, from processor assigned to reserves established. So that's why, whenever you add resource dependencies, you will only increase this processing time. You can never reduce it. Because if there are no defined resources, then we just use whatever time we have according to the histograms. But if you add resource dependencies, then there's a chance you will add some waiting time to that. I'll start our simulation now, and we'll see the results. We see that if we add 17 agents to our transition, we will increase the duration of the transitions to the reserves established event, having 3 months of waiting time on average. But when we already have resources included in the project, simulating the resources becomes a bit tricky, because when the data is recorded, this waiting time is already included in the calculation of the transition durations when they recorded the data. Thus, we now simulated adding 17 agents to one node, but in fact, we simulated the process as if it had 34 agents, as there are 17 agents already active in the original project. So if we want to simulate the process with already calculated data, which includes waiting times, we can change our multiplier value to try to have the original processing time and the simulated time with resources defined the same or close to each other. For now, we have the following results. I'll delete the results and change the multiplier value. And then what happens is that when we simulate it, we still have some waiting time, but the processing times will be shorter. So this is the calibration phase, when we tweak this multiplier value until the results show the same, or pretty much the same, average transition duration as in the original data. By the way, tweaking can be done not only by adjusting the multiplier, but also by changing the histogram or by both. We're now seeing the result of such calibration. the average transition in our simulation results is almost the same as the original. And if we have that, then we can say that we have a model which has these 17 agents as a resource requirement, and they produce the same transition time as the original. And now, if we want to see what happens if we add more agents or decrease their number, then we can change the number of agents. And that will decrease or increase the duration between the events correspondingly. I'll add 3 agents, run the simulation, and our 31 average hours turns into 2 hours. Or we change the agent number to 15 and see that our 31 hours turns into 6 days. You should have a fairly good idea about the original resources involved in the process so that this calibration and analysis makes sense. Also, keep in mind the option to add resources to all the nodes. Using the resources feature in simulation will help you get a more accurate picture of how allocating resources can influence your process.